So the first section of our book for chapter 2 is called Angles, Arc Length, and Circular Motion. So you guys will learn about angles and measuring in degrees, how to convert between decimal and degrees to degrees, minutes, second measures, which is a really interesting old school kind of idea. And we'll talk about that when we get there. How to find the length of an arc of a circle. How to go back and forth between degrees and radians or radians and degrees. And then how to find the area of a sector of a circle. So today's date is the 24th. So just to give you guys an idea, today's the 24th, right? Your chapter 2 test is like the first week in March. That's how long it will take us to get through chapter 2. It's long. All right, so angle terminology. So an angle is defined as two rays with the same endpoint called the vertex. The measure of an angle is the amount of rotation required to rotate one side. Called the initial side. What's another word for initial? What? First, or like when something like begins, right? So like the starting side. So this is like the start. Okay. To the other side called the terminal side. So when something terminates, it's when it ends. All right, so let's talk about what standard position means. Okay, an angle we say is said to be in standard position when the initial side is on the positive x-axis and the vertex is on the origin. So we're going to draw a picture here in a second so that way you guys know what I'm talking about. Positive angles are angles generated by, and this should sound familiar from last year, counterclockwise rotations. Which means that negative angles are angles generated by the other way, clockwise rotations. Bless you. So positive angles are counterclockwise. Negative angles go clockwise. Two angles that have the same initial and terminal sides are called coterminal angles. Highlight this because this is important. Okay. A lot of the math that we learned, we came from the Greeks. Okay, so a lot of times in trigonometry, we're going to use Greek letters instead of our traditional Roman letters. You will typically see Greek letters used to label angles, such as alpha. Okay, the Greek letter alpha, the lowercase alpha, looks like a fish. It looks like this. Okay. They're not gonna look great the first few times you guys draw them. Just you'll get better with practice. Okay. Beta is my favorite one. I like beta, but it's basically, it looks like a capital B, but it has a really, really, really long front leg. So something like that. And theta, which is one that you guys are familiar with. So it looks like a zero, but has a line through the middle. And then sometimes we just use the letters that we like, A, B, and C. Okay? All right, so let's draw some pictures so you guys can have some familiarity with what this is. Okay, so I want you guys to draw a point. And then from that point, I want you guys to draw a ray that looks like this. And then a ray that looks like this. So if I start on this side and draw an angle that looks like this, I'm going to call that alpha. Then this would be the initial side. And this would be the terminal side. And then this, of course, is the vertex. Okay, so my question to you guys is, by the way I drew that, did I go clockwise or counterclockwise? Counterclockwise. So this picture shows a counterclockwise rotation, which you guys can abbreviate counterclockwise like this. So since I went counterclockwise, is that positive or negative? Positive. So this would be a positive angle. Okay? All right. I want you guys to draw the same angle. Not the purple part, just the same rays and the same vertex. So something like this. But now I want the angle to look like this. I'm going to call this beta. So this would be an example of a clockwise rotation. which we'll abbreviate as just capital CW, which means that this angle would be negative. All right. Another way that this could look like is something like this. All right, so this right here, is this positive or negative? It's positive, so this is counterclockwise. So this is a positive angle. So what I want to demonstrate to you guys is these all look different, right? These all are different angles. However, do you guys see how we all started from the same place? Each angle begins on the initial side. And then look where the arrows are. All the arrows meet on the terminal side, okay? But this is not the same degrees as this, and this is not the same degrees as this. These are all different angles, but they all landed and started in the same places, okay? So this would be an example that alpha, beta, and theta are called coterminal angles. Okay. All right. Oops. All right, so let's practice drawing these. So let's sketch each angle in standard position. So for part A, I want us to draw a 45-degree angle. So standard position means that an angle begins on the positive x-axis, okay? So hopefully this sounds familiar from last year. If I were to rotate all the way around, think about a full circle. How many degrees are in a full circle? 360. We have 4 quadrants. So that means each quadrant is basically a measure of how many degrees? 90 degrees. Every quadrant is 90 degrees. So if I'm rotating positive 45, remember that's counterclockwise. So how far do I rotate if it's 45 degrees? Half, because half of 90, good morning, is 45. Okay, so just remember that 90 degrees divided by 2 is 45. So I'm basically going to draw an angle that looks like this. So about halfway. And then let's just label it that this is going to be theta, which is 45 degrees. Okay, does that look familiar from last year? Okay. So for part B, oh, I didn't write down the angle. My bad. So we're going to do negative 90. So negative, remember that means we're rotating in a counterclockwise direction. You always start on the positive x-axis. So negative 90 degrees. Remember each quadrant is worth like 90 degrees. So that means I'm basically going to land on this axis. Okay. So if I want to draw this, this would be like my initial side. Can you guys see that? It's purple. That would be my initial side. My terminal side is going to be right here. And my angle is going to rotate something like that. All right, C. All right, let's do 225 degrees. So it's positive, right? So I'm going to be going this way. So this is what? 90? How much would that be? 180. So full circle is 360. So half the circle is going to be 180. So how many more degrees do I need to rotate to get to 225? 45 more. So remember 45 is about halfway through a quadrant. So it's going to look something like this. My terminal side is going to be here. My initial side is going to be here. So something like that. So theta is equal to 225 degrees. All right, let's do one more and then we'll stop for today. So, what do we notice here? It's over 360. So when we do this angle, it's positives. I need to go all the way around and then think about how much more rotation would I need. So remember, a full circle is 360. So basically 360 plus how much more do I need to go to get to 405? 45 more. So it's going to look like this. 405 degrees is the same thing as 360 plus 45. So I need to go something like this, all the way around, and then plus another 45 more. All right, let's pause here, guys.